In this video, I'm going to show you how to find different pieces of information from the three forms of quadratic equations. So the first one we have here is standard form. The basic version of standard form is written up here with an example written down here. So one thing we can find from standard form is the vertex. Now, to find the vertex from standard form, you have to do two steps. The first thing you have to do is find the x value of the vertex. So to do this, you do negative b divided by 2a. So if we look at our example, b is negative 4 and a, although it's not technically written, is 1. So because my b is negative 4, negative b would be positive 4. So that's 4 divided by 2 times a. So 2 times 1, which is 4 divided by 2, which equals 2. So I know that the x value of my vertex is 2, and we don't know what our y value is yet. But to find the y value, all you have to do is substitute the x value into the original equation. So what that would look like is this. If my original equation is x squared minus 4x plus 5, and I know that x is 2, I substitute 2 in for x. So 2 squared is 4, minus 4 times 2 is 8, plus 5. And this again is going to give me the y value of my vertex. So 4 minus 8 is negative 4, negative 4 plus 5 is positive 1. So my vertex is located at 2, 1. Now the next thing that I can do from vertex form is I can locate my axis of symmetry. Now the axis of symmetry is easy to identify because it passes through your vertex. So if you know what your vertex is, you know what your axis of symmetry is, because your axis of symmetry is always written as x equals and then the x value from your vertex. So for this example, my axis of symmetry is at x equals 2. Because it's the x value of my vertex. Now the other thing that you can find from from standard form is you can identify if your vertex is a maximum or a minimum. And this all depends on your a value. So if we look at our original equation in vertex form, our a value is a positive 1. Now because it's positive, that means that our parabola is opening up, which makes our vertex a minimum. So if you see here, I drew a little sketch for you. So here's your vertex, it's positive 1, so your parabola is opening up, meaning that your vertex is the lowest point of that parabola. Now if a is negative, then your vertex is your parabola is opening down, making your vertex a maximum, as seen from the sketch here. Now the last thing that you can identify, actually not the last thing, we got 2 more things for standard form. One of the last things that you can identify from standard form is whether or not your parabola has a vertical stretch or a vertical compression. And again, this depends on your a value. Now, because a is 1, it's not really shifting as much of a vertical stretch or compression, so it would just be a standard parabola. However, if the absolute value of a, that's what these 2 lines mean, absolute value, if the absolute value of a is greater than 1, then it has a vertical stretch, meaning that it's getting narrow. So if we were to draw something that's getting narrow, like a narrow parabola, here's my graph. A narrow parabola would look something like that. Versus if your absolute value of a is less than 1, then you have a vertical compression. So it gets wider. So if this is our graph, it would look something like this, where you can see that this is a lot more narrow and this is kind of being like stretched or compressed. And the last thing that you can pull from your standard form is your y-intercept. And for all parabolas, since they are functions, you're only going to have one y-intercept. So the great thing is your y-intercept is always going to be your c value. So if we look back up here, my C value in this example is 5. So my y-intercept can be written as 0, 5, or y equals 5. Okay, so it looks like that. 0, 5, or y equals 5. So that's all the information that you can pull from your standard form. The next one we have is vertex form. So in vertex form, you can obviously pull the vertex. Your vertex in vertex form is h comma k. So if we look at the example that we have at the top, we have -1. Okay, this negative sign means -1. X minus 2 squared plus 1. Now, if you remember correctly, h value of your vertex is always the opposite sign. So although this looks like a -2 inside my parentheses, this 2 is actually positive because in our original vertex form, it's always minus. So in this example, it's not a -2 h value, it's a positive 2 h value. And my k value right here, this sign does not change. So because it's a positive 1, it remains a positive 1. So there's my vertex. Now, just like everything that we identified with standard form, you can also identify the vertex, or sorry, not the vertex, the axis of symmetry, whether or not your vertex is a maximum or minimum, and does it have a vertical stretch or compression. Now, the only thing that you can't pull from vertex form that you could pull from standard form is the y-intercept. Okay, so everything that we covered as far as axis of symmetry, maximum or minimum, and vertical stretch and compression is the same for standard form and vertex form. Now, just to show you for axis of symmetry within vertex form, it's still the same. X equals X value from your vertex. So if this is my vertex and I have 2 as my X value, my axis of symmetry here is X equals 2. If, let's say, our vertex was -4, +3, our axis of symmetry would be X equals -4. Okay, last form of a quadratic is factored form. Now, in factored form, you have 2 binomials. The binomials are what we have written here in parentheses, and you have an a value on the outside. Now, for this one, you can find your roots. Roots are also known as your x-intercepts. You might hear them referred to as solutions or zeros. They all mean the same thing. Roots, x-intercepts, zeros, and solutions all mean the same thing. They're all your x-intercepts. So how do you find them? Well, to find them, you set each binomial equal to 0 and you solve for x. So I'm going to take this first one, x minus 6, and set it equal to 0. Now I just have to solve for x. So to do that, I would add 6 to both sides, and I get x equals +6. So there's one x-intercept, and I can also write it as a coordinate. Then I take the other binomial, which in this case is x plus 7, and I also set that one equal to 0. So to solve for x, I would subtract 7 from both sides. So I have x equals -7. Or you can write it as a coordinate, -7, 0. One other thing that I want to mention to you when we're talking about parabolas is you are always going to have either 0, 1, or 2 roots. You're never going to have more than 2 because then it's not a parabola, and you can't have anything less than 0 because you can't have negative intercepts, a negative number of x-intercepts. Let me phrase it that way. So you can always have 1, 2, or 0 x-intercepts. Okay, so that's how you're solving for your roots within factored form. Now, the other thing, just like we said with standard and vertex form, is you have that a value outside this parentheses. Remember, if there's no a value here, it's an automatic invisible 1. But in this case, our a value is 1/2. So what we know is true from vertex form and standard form. A value determines if your vertex is a maximum or minimum, if your parabola is going to open up or down, and it also determines if you're going to have any vertical stretch or vertical compression. So because this A value is 1/2, the absolute value of A is less than 1, which means that our parabola is going to have a vertical compression, meaning that it is going to appear wider if we were to graph this. So take a moment to write this down, and then you are completely done with your notes for today.